All right. So, good morning, everyone. Welcome to another class sa APLTRIG lab. So, for today, we're just gonna discuss our quiz that you just took last week, and we will be just discussing about vectors. So, today, wala tayong exercise and more of like just discussion now. All right. So, let me just share my screen. Okay. Kita naman. Okay. All right. So, back to our quiz. We have a watchtower that is 20 meters high. There's an arch on top of it. Tower is built on top of hill, inclined by 40 degrees. So from the ground, the archer is stationed 52 meters high. He can shoot within 75 meters. Archer can hit an enemy every 2.75 seconds. The archer deals 10 damage every time he hits the enemy. Then, our monster is spawned at 250 meters from the tower, and it has 85 HP and moves at 3 meters per second. So first question, what is the length of the slope of the hill? Now, nakasabit dito, 40 degrees to, and all that are given is 52, 20, 250. We have no idea what this is though. We cannot deduct it from our 250, but we know that it is a 20-meter high tower and the archer is 52 meters from the ground. Which means this side is 52 minus 20, which is 32. This is 32. So, to get this slope in our hill, we use our sokotawa. So in this case, we use sine. Sine 40 is equal to 32 over the hypotenuse. We isolate it. 32 over sine 40. 32 divided by sine 40 is 49.78. 49.78. That is answer for number 1. Next, from the ground, what is the effective range of the archer? So noon, if you recall, I used a circle here to represent the range of our archer. And I said that it is 75 meters, meaning in the circle the radius is 75, right? So when it reaches the ground, you will notice that this is 75. We have a height here of 52. So all we have to do is find out this effective range from the ground. So you recall this is 75. We are looking for this one, which is 75 squared. Here. 75 squared is equal to 52 squared plus x squared. Isolate x in one side, we have the square root of 75 squared minus 52 squared. So 75 squared minus 52 squared square root 54.05. X is equal to 54.05. That is the effective range. So far, any questions? No? No questions? Okay. 3. How long does it take before the monster gets in the range of the archer? So how long from the starting position would he get to the range of the archer? So we know that it is 250 from him to the tower, but we know that the effective range of the archer from the ground is 54.05. So what is this blue? This blue part is 250 minus 54.05, which is 190.95. Double check. 250 minus 54.05, 195 point, oh, 195.95. So that is the length here. And let me just put this here. But the question is, how long would it take? If you remember, distance is equal to time times speed. Our distance, 195.95, is equal to the amount of seconds times ang speed is 3. So we isolate the t, 195.95 divided by 3 is equal to t. It will take the monster to be in range 65.32 seconds. Kung ano naman, 65.32 seconds. That will how long it will take to reach the range of the archer. So this one, let us put this here. It'll take him 65.32 seconds. No question? Okay. Assuming that the monster will not die, how far does it need to travel to reach the tower? So ang given kasi dito is nag-spawn siya 250 meters from the tower. But we did not take into account this slope. So the actual distance is from the spawn point to here, and then the slope here. So all we have to find out is what is this? What is this length? So we can decrease it from 250 and then you're able to add the slope, and that will give our distance, the actual distance. So this purple is, to get that, let us try to get itong part na to. The base of our triangle. So in this case, we can do tan 40 is equal to 32 over our base. Isolate x, 32 over tan 40. X is equal to 32 divided by tan 40, 38.14. 38.14 carry. Now we have to round it up. So this is 38.14. So our distance here, our actual distance, is 250 minus 38.14 plus yung slope 49.78. We do the math. 250 minus, oops. 250 minus 38.14 plus the slope 49.78. We get 261.64. This is the actual distance. Any questions here? Kuha naman. Gets nyo naman to? Okay. No questions. We will proceed. Number 5. How long does it need to take the archer to kill the monster? So we need to remember that the archer can't hit the monster until it's within the range, and you have to consider the acquisition time. So first, how long would it take? Again, from here to here, answer was 65.32. Yan yung acquisition time natin. Now, how long does it take the archer to kill the monster? To get that, remember, up here, remember that the health of our monster is 85. How many hits does it need to take to kill? We divide it by 10 because that is our damage, and we get our ceiling. So ceiling of 8.5 is 9. It will take 9 hits to kill him. And how long does it take to do that? 9 times 2.75. It will take him 24.75 seconds to kill him when in range na si enemy. So we add this up. 24.75 plus yung acquisition time 65.32. It will take him 90.07 seconds. So it'll take him 90.07 seconds. All right. Any questions here? Wala. Okay, okay. Now, finally, what is the remaining HP of the monster if it reaches the tower? Right? Zero if it's killed before it reaches the tower. Okay. So first, how long would it take him to actually reach the base of the tower? So we have this purple one here. It took him, the actual distance is 261, right? 261.64 divided by his speed. We get how long it would take him to get there. 261.64 divided by 3. It would actually take him 87.21 seconds. Right. Minus the acquisition time, 87.21 minus 65.32. Wrong one. 87.21 minus 65.32. It would take him 21.89 seconds to reach the tower habang inatake siya. In range siya ng archer. So how many hits did the archer do within this 21.89 seconds? We do is 21.89 divided by how long does it take him to attack? 2.75 seconds. And we ceiling or floor? No. Anyone. Ceiling or floor? How many hits does it take? Right now I'm dividing how long it'll take him to get there. Wow. Magaling. Floor. We floor this. So, round one again. 31.89 divided by 2.75. 7.96. But we floor that. 7 hits. The archer dealt 7 hits while the monster was going up. So, remember, his health is 85. 7 hits. Oh, sorry. Times. Minus. 7 hits times 10 damage. We are left with 15. His health will be 15 HP when he reaches the tower. Talo si Archer. That is the remaining HP. Okay. Now, there's another answer to this. How we answer this right now is we had to make the archer wait for him to pull his bow. The 2.75 seconds, we had to wait for him to pull that, and then mag-atake siya. So, another way though is when our enemy has reached the range of the archer, atake agad si archer. So, instead of 7 hits, would have been 8 hits. Kasi he attacked right away. So 8 hits. So instead of 85 minus 8 times 10, he would have had 10 HP, right? So that's our second answer for this. There's a second answer into number 5. So how long does it need to take the archer to kill? Instead of 9 hits, sorry, uh, it take him 9 hits, right? We could actually decrease another 2.75 from our answer. Kasi he shot right away. So instead of 90.07, it would be like 90.07 minus 2.75. 90.07 minus 2.75. 87.32 seconds. That is the second answer. Okay? Any questions? Kuha naman. Sige. So, that's it lang for our quiz. I have a simulation here, which is basically it has the same parameters. You have the height, you have the archer height, we have the incline of our hill, we have our radius, we have kung saan siya nag-spawn from the base of the tower. So that's all taken into account here. So if I play this, we have our monster slowly getting to in range of our archer. And we said that it will take him 65.32 seconds to reach the range of the tower, of the archer. So we're gonna wait for that. Unless you guys want to skip, we can skip it also. So yeah, while it's doing that, I'm trying to look for 87.21. Okay, we're skipping. It's going faster, it's going faster. So you'll see that when he reaches the range, ang sabi dito, nakita niya yung enemy at 65.34. Tama ba yan? 65.34. What was your answer there? But anyway, we'll get to that. Going up here, and 87.22. So we still have some health here. Check natin yung ano. How long did it take? 65.32. What did it say here? 34. So medyo off siya by 0.02. But everything else is correct. See, 87.22. Did we get that? 87.21. Yeah, so it is a bit off by 0.01 seconds. But, you know, it really just be like that. Right? So, kita naman. Tama naman siya. Okay, any questions? Any violent reactions? May problema kayo? Wala. Okay. Sige. So, that is our quiz. I will be checking it later. Ito yung mga sugot natin. And expect na lang yung yung results niyo mamaya. Okay, okay? So yeah, that's it for quiz. We can go to our discussion for today, which will be about vectors. Now, vectors are very important in our game dev. It is how we use to get our distance, we use to get our direction, and anything space related. I mean, positions and whatnot. We use vectors. So, what is a vector? A vector is an entity that has both a direction and a magnitude. So in physics, velocity is a vector because it describes the speed pointing to a specific direction. So in games, though, vectors can be used to determine a position relative to an origin 0, 0. You can often see this when navigating a map. And this is different where it only describes different from scalar where it only describes a magnitude. So in scalar is only gives like a speed, a length, but the vector, it describes a direction where it's going to and how fast it's going to that direction. Okay. So vector magnitude, we use our Pythagorean theorem for this, just like a while ago. So in order to get this, you just get the square root of the squares of x and y. Yeah. Square root of the addition of the sum of the squares of the x and y. Anyway, I mean, you know how Pythagorean theorem works. X squared plus y squared is equal to z squared. Ayun. So to get the magnitude, you just have to get z. Kapag 3D vector, it's almost the same thing except that you have an additional third component. Yung z. But you solve it the same way. Ang vector addition, it is used to accumulate difference described by both vectors into a final vector. Vector addition is both commutative and associative. What does that mean? You don't really have to care where the placement of our vectors are. You can place it anywhere. Right. So if an object moves by a vector and then by b vector, the result is the same as if it will have moved by c vector. So if you line them up together from end to end, you will get where he would have just went if he didn't have to take this longer route. Itong c vector. So it is computed by simply just adding yung components niya, yung xyz, ng dalawang vectors. Add them together, you get yung where the final position or the vector c would be. So for example, if an object is at 5, 5 and you want to move 5 units to the north, which is 0, 5, you get 5, 10. If a unit has a velocity of 1, 1, that unit will continuously accumulate velocity vector to its current vector. So, let's say given a plane, let's say nasa where am I? Let's say we're here, right? And sabihin natin we are going to 1, 2. Our velocity is 1, 2. 1, 2. Meaning, from our position, it have went 1 unit to the right and 2 units up. And you can accumulate it. Let's say another second passed by. Our position would have been where we were, and then 1, 2, 1, 2, and so on and so forth. It is just adding our vectors together. to get our final position. Ito. So, kung nag-add pa ng isa pang, 1, 2, it will been here or something. Ito. Okay. Okay. So that is vector addition. It is literally just adding our two vectors. Vector subtraction is a completely different thing. The second vector is inverted and added to the first one. So this can be used to determine the distance between two vectors. It can also be used as to get the direction from vector direction of vector B from vector A. So in games, this can be used when an object is chasing a target. So what does that look like? If I have a vector, if I have a vector A here and vector B right here, I can know the direction and magnitude, direction, the distance by simply subtracting this two. So itong part na to, given like A and our B here, I can get our direction and our magnitude by simply subtracting these two vectors. But one important thing here is which one are we subtracting from who? Now, this one, important. The order matters. So, kapag B minus A is equal to C, A is facing towards B and B is facing away from A. Kapag A minus B is equal to C naman, B is facing towards A is facing away from B. So, if I do B minus A, this is where we are. This is where we're looking at. Our direction would be here. This is B minus A. If it is A minus B, this is where we were. This is where we go. We're looking at. Our direction would be the opposite. Okay? So it matters. The order matters. Any questions so far? Wala. Okay. So we can get our magnitude using the distance formula in space. So I hope you guys don't get too scared about this. This is simply just our Pythagorean theorem. Given this is x1, y1, x2, y2. This is our triangle right here. Ito yung triangle natin. And to get this length, this will just be x2 minus x1. To get this length, this is y2 minus y1. So, our magnitude right here would be d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. This would be our magnitude or our distance. All right. So yan yung distance formula. Just, you don't have to cry about this. Medyo parang take your time lang yan. Any questions about our distance here? Distance formula in space? None. Okay. Now we go to vector scaling. So you can scale a vector by multiplying a scalar value to the vector. So the vector multiplication doesn't change the orientation or direction of the vector. However, if you multiply it with a negative scalar, it will just flip the orientation of the vector. Dividing a vector is used for normalization or downscaling the magnitude of the vector. What does that mean? So, what if I have a vector right here? Let me just delete this. What if I have a vector here of 2, 3? That's my vector, 2, 3. I could scale it by multiplying, let's say, by 2. If I multiplied by 2, this would be like 4, 6. It is still the same direction, except that we just made it a bit longer, itong vector natin. What happens when you scale our vector. It is the same direction. It's just that we have a different magnitude. Same thing if you multiply by 3, ayun, it'll still be the same direction. If we multiply it by a negative number though, like -2 or -3, it will be going the opposite way. It will be facing here. Let's say -2. We multiply the vector with a -2. It will be like -4, -6. It's just the opposite direction. Opposite orientation lang of our vector. Same thing. You can divide it. You can actually divide it. See, so we can divide it by, let's say, 2, right? It'll be like 1 and 3/2. Again, same direction. It's just that we have a different magnitude right here. Now, this one, quite important in game dev, vector normalization. So a vector whose magnitude is equal to 1 is called a unit vector or a normal. So this is used to isolate direction from the magnitude. So this will make computations with regards to direction a lot simpler. To get a normalized vector, just divide each component of the vector by its own magnitude. So let's say we have a vector here of 3, 4. We have a vector here of 3, 4. First, we need to get our magnitude. Magnitude, simply just it's like our Pythagorean theorem here. Here's our triangle. So it is the square root of 3 squared plus 4 squared. Our magnitude is 9 plus 16, square root of 25. It is 5. Our magnitude here is 5. So if we look at our triangle, it would have been like this. That's 5. This is 3. This is 4. To make it a unit circle, we need our magnitude to be 1. That is why we divide everything by our magnitude. We end up with a normal of 3 over 5 and 4 over 5. This is our normal. All right. So, example, if you want to fire a projectile towards a specific direction, we want to define direction in the form of a unit vector. So, to determine where the linear projectile will land, just scale the unit vector by the magnitude. The range of the projectile represents the magnitude. Where will the linear projectile will land? Okay. So, parang ganito. We were able to get our normal to be 3 over 5 and 4 over 5. What if I want to know how far would it be if, let's say, ang speed niya is 20 meters per second. Yan yung speed niya. We simply just multiply it by our unit vector. So it's like 20, we have 3 over 5 and 4 over 5. He will end up at 12, 16. Okay. That's one use for our normalization. So if an object is facing directly north, then the object's unit vector is 0, 1. Because that is our 0, 1. 1 would be our magnitude. This is 0, 1. That is our normal if our vector is facing up. Any questions here? No questions? Or you have any questions like about the vectors, adding or multiplying? Okay, wala. Continue. So, to summarize, addition, you can place it anywhere. And if you add it, it simply just tells us where our final position will be given the vectors. So, C is equal to A plus B. Current position, and then our movement vector. Is yun ganun. Let's say I started from A, I move with B. You just add them together, and you get our new position. Subtraction will determine the distance between two objects, and it can also determine the direction from one object towards the other object. In order to do that, we must find out ano yung A, ano yung B natin dito. So, kapag C is equal to A minus B, A is the vector we need to look at, and B is the vector where we're looking from. Alright? So, scaling naman, it changes the magnitude of the vector without changing its direction. Simply put, it just multiply lang a scalar value. And normalization, we shorten the vector to have a magnitude of 1. And again, to do that, we just divide our vector with its magnitude. So, a vector with a magnitude of 1 describes a direction. Alright? So, how do we use this in practice? Assume that object A is the unit. A is the unit and object B is the tree. If your vector represents positions of object A and B, yung B minus A will be the difference vector between the positions. Meaning, it will be kung ano yung distance natin from it, ano yung direction natin to the tree. That is B minus A. If you add A and B, it describes the vector projected from the origin to the tree. Meaning, let's say, galing si unit sa tree, and then with his vector, he added, yan yung ano, yan yung projected vector. Saying na parang galing siya sa tree. Or other way around. Si player origin, tapos yung tree yung ano, tree yung position. Yeah. That is ano, when you add. No matter where you place A or B, same thing. So if you want A to move to B within 5 seconds and you want to know the velocity of the object, you have to do these following steps. You have to find out yung velocity. So the unit is moving towards the tree within 5 seconds. What is the unit's velocity? Una, you need to find the direction by subtracting B from A. B yung tree, A yung unit. That way, we know what direction the unit must be going to get to the tree. We get the distance between A and B by getting the magnitude of C. So, if we know the distance, we know that we must be there in 5 seconds. We will get the speed that we need the unit to be going para maabot niya yung 3. So, that will be like the magnitude divided by 5. Then, we normalize our C vector so that we can have a direction lang with a magnitude of 1. Then we can multiply that. We can multiply our speed to our normalized C. It's a bit mouthful, but it kind of looks like this. Let's say the unit is at 1, 1. Let's say the tree is at 4, 10. No, let's make it simpler. Wait lang. 7, 9. Right? So, una, we need to get our distance and magnitude by getting ito. So to get this, we just, again, subtract B, where we want to look at 7, 9, from A, where we're coming from. So think about it. It's like a triangle, or right triangle right here again. So we subtract it. We have 7 minus 1. No, sorry. This is 7 minus 1. And we have 9 minus 8. Which is like 6 and... sorry. 9 minus 1. We have 6 and we have 8 right here. So itong arrow na to, this is 6, 8. To get the magnitude, remember, we get the square root of 8 squared plus 6 squared. 8 squared plus 6 squared. The square root 10. We have 10 here. And ang sabi niya, I want to be there in 5 seconds. So, in order to cover 10 units in 5 seconds, we simply divide the magnitude and the speed and the time. We need to move 2 meters per second. This is our speed. So, what should be his velocity? Next, we need to get our unit, our normal here. Itong normal natin. Si 6.8. So remember our 6.8 here, right? To get the normal, we just divide it by our magnitude. So our normal is actually 6 over 10 and 8 over 10. Or simply put, 3 over 5, 4 over 5. This is our normal. So what velocity does he need? We just multiply our speed to our normal vector. In this case, it is a 6. His velocity must be 6 over 5, 8 over 5. Or 6.2 and 1.2 and 1.6. This has to be his velocity. Alright. Parang ganun lang. Ganun lang yun. You just subtract it and then find out the normal, find out the speed, and you'll get that. Another one, normalize and movement sample. So to normalize our vector of, let's say, where we want to go, again, it is 1 squared. The square root of 1 squared plus 6 squared. One squared plus 6 squared. Square root of that. 6.08 right here. To get the normal, divide our vector with the 6.08. So if I want to move by 2 units facing towards our normalized vector, we multiply it by 2 and we get 0.82 and 1.98. So let's say our current position is 10 and 3. We just add it lang. We get 10.32 and 4.98. Alright. Sample lang yun. Any questions? Hold on. Give me a second. Alright. No questions? All good? Sure kayo? Get na yung concept of normalization, velocity, direction. Okay. So the following slides here, I won't be quizzing you about it. It is just additional information you could use later on maybe Pero lahat to, lahat itong following slides, I won't quiz you on this. Okay. So una, we have the concept of our surface plane. So surface plane is a normal vector. Can be used to describe the direction of a surface plane where a surface plane is facing. So let's say ito yung plane natin. Our normal vector is where it's facing. So a plane is an infinite slice of a world in half at a particular point P. So the rotation of this plane is defined by the normal vector n. So ito yung kung saan siya nakatingin. Now, a dot product. So, yung dot product, it is used to extract the angles between vectors. It only works for yung mga 3D vectors. If you use it on two normal vectors, it represents the rotation between these two vectors. So if the dot product is 1, they are essentially facing the same direction. If our dot product is 0, then the two normals are perpendicular, meaning they create a 90-degree. If the dot product is -1, they are facing opposite directions. All right. Now, where can this be used? Where can this be used? In game dev, we have something called backface culling. It is something na we use to optimize yung game natin by not rendering parts of a surface. So backface culling is an optimization technique which drops computation on polygons whose surface normal is hidden from the viewer. Yun nga, tinatago natin sa viewer. So construct a vector from a viewer and take the dot product of this vector and the surface normal. Meaning kung asan nakatingin itong surface na to. So kung positive yung result, the viewer is looking at the backside of the polygon. So do not render. So if you look here, if the plane is facing, okay, maybe this will work. If our plane, let's say 3D to. Let's say we have a plane here that is facing here, and we have a person here, or tayo to. And we are looking here. Itong dot product na to, since they are facing the same direction, is 1. Or a bit, basta positive siya. Meaning, we are looking roughly the same direction. It will not render it. Because we are essentially looking at the back of this plane, which is nothing. So we won't render it. So para hindi sayang yung polygons natin. If the result is negative, then the viewer is looking at the front side of the polygon. Render it. So if you're here naman, any direction, if you get the dot product of this vector with this vector, it is roughly negative, which means we are looking at the surface. So we must render it. So that is backface culling. Next, we can also use this light. So suppose you're writing a light shader and you need to calculate the brightness of a pixel at a point. We have the normal vector, which represents the direction of the surface, kung let's say kung anong uh, normal, kung saan siya nakatingin yung surface. We have the position of the light. And we have the position of the surface point right here. Given all these three, we can get the direction of the light from the surface by subtracting the position uh, from the light's position, and we can also get the dot product between the surface normal and the light direction. Doing so, we know how bright or how dim it is given the uh, distance. So, let's say, itong sample na to, makikita nyo, sobrang bright nito because we know this normal, the dot product of this will make it so that it'll be really bright here. Okay? So this one, usually we don't really touch it. We don't really touch light. Ano. Pero, unless you guys create a game that uses some type of light na gusto nyo gawin, ayun, sure. Kind of useful. Right? We also have here cross product. It's another operation of with vectors. So a cross product results, if you cross product two vectors, the resulting vector is perpendicular to the first two vectors. The length of the resulting vector is the average of the length of the two vectors. So very important yung order ng vectors nito. It depends on which one is which. Kasi if you switch the order, we get the same length but opposite yung direction nila. Okay? So this could be used for collision. Launcher moves into a wall at an angle. The wall is frictionless and object should slide along its surface instead of bouncing. How do we calculate that position? So we have to define the vector of the wall where it's going to, which this represent the distance of the object should have moved if there was no wall. We'll call that change. So assuming na andito na yung bola, we get the normal vector of the surface wherever it's facing at. Then we get the perpendicular vector to the change and the surface of the normal. We use yung cross product. Ang final direction is wherever the ball would slide. Right. So ibang direction is the change cross. Change the cross the cross product of the change and the plane normal. And the cross of that and the plane normal again. Yeah, bit complicated. We can also use these to compute the distance of a point to a plane. So to calculate the shortest distance from some point to a plane, we get the distance vector to any point of the plane, and then we should not normalize it, and multiply it with the plane's normal vector. Then we use dot product, the point minus plane point getting distance, and then we dot it with the plane, the normal of our plane. So is the point on the plane? It's on the plane if our distance is 0. Is a vector parallel to the plane? If this vector is parallel to the plane, then sure, it is. Vectors are perpendicular to each other if their dot product is 0. Alright? So this is what it looks like for our symbols. In cross product, usually A X B. Iba siya sa action multiplication. So A X B or A cross B. Kapag dot product, A dot B, or usually it's a dot in the middle. So do you guys have any questions? No questions? So again, itong part na to, cross product, dot product, hindi siya kasama sa quiz nyo, which is not next week. So next week, we'll just be having exercises lang. So lahat to, from surface plane until the dulo, wala. Hindi siya kasama sa quiz nyo. So what if ever we'll have a quiz, it'll be about yung vectors, normalizing, addition, subtraction of the vectors, velocity. Ayun. That would be our quiz. But for next week, we'll just be having exercises lang. Alright? Any questions? Silent reactions? Kung ano naman lahat. I hope this is clear. I hope the part na to is clear. Very useful. You actually use it sa game dev. Especially mga programmers natin, you would need to know like velocity or direction. Ayan. You really need that. So you just have to remember, especially yung subtraction. Which one is which? Kailangan nyo malala. Ano yung dapat yung negative. Okay? So, if there are no questions or any concern, that's it lang for today. You guys can go and have your Friday.